Finding the pH in a solution of a base. Now, if you have a solution of a strong acid, it's really easy because pH equals the negative log of the hydronium ion concentration, and if it's a monoprotic acid, then that equals the concentration of the solution. But how do I do it when I've got a solution of a strong base? Again, pH equals the negative log of the hydrogen ion concentration. But how do I figure that out? I know that I've got sodium hydroxide, and that is a very soluble ionic compound. So it's 100% dissociated into sodium ions and hydroxide ions. So that means that the concentration of hydroxide equals the concentration of the solution. But how can I then relate the concentration of hydroxide to the concentration of hydrogen ions? The answer is that the concentration of hydrogen ions times the concentration of hydroxide ions equals 1.00 times 10 to the negative 14th at 25 degrees Celsius. So to solve this question, I could determine the H plus concentration from this equation. H plus will just equal 1.00 times 10 to the negative 14th divided by the hydroxide ion concentration, which is the same as the concentration of solution. So I can plug in some numbers. The H plus concentration is 1.00 times 10 to the negative 14th divided by 2.3 times 10 to the negative 3rd. That's the concentration of hydroxide. So that gives me that the concentration of H plus equals 4.3 times 10 to the negative 12th molar, which I can now plug into the pH equation. Recall, the pH equation is pH equals the negative log of the H plus ion concentration, so that's negative logarithm of 4.3 times 10 to the negative 12th which gives me 11.36. 2 sig figs in my concentration, 2 decimals to the right in the pH. We could also make a substitution here because we know that the concentration of H plus equals 10 to the negative 14th divided by the concentration of OH minus. So we then get pH equals the negative logarithm of 10 to the negative 14th over the concentration of hydroxide, which if you do some algebra you get 14 plus the logarithm of the hydroxide ion concentration. So let's try that with the problem we did before, where the hydroxide ion concentration is 2.3 times 10 to the negative 3rd molar. So we get 14 plus the logarithm of 2.3 times 10 to the negative 3rd. Punch that into my calculator. and I get the same answer, 11.36. Here's an exercise for you to try. This one's just a tiny bit trickier, because when calcium hydroxide dissolves, you get two equivalents of hydroxide ion. Pause your video and work the problem. When you're done, unpause to see my solution. Here's my answer. The concentration of hydroxide ion is going to equal 2 times the concentration of solution right, and that 2 comes from the coefficient 2 on hydroxide in the balanced equation. So that gives us 6.66 times 10 to the negative 2 molar. We then plug into our pH equation 14 plus the base 10 logarithm of the hydroxide ion concentration, so 14 plus the logarithm of 6.66 times 10 to the negative 2. And I get 12.823. 3 digits, 3 digits.